Okay, so these two questions for this quiz were both at the unit exam 5 years ago. They are exactly the kind of thing I will continue to ask on a unit exam. All that will change is the context. Okay? But these are exactly the kinds of things that would appear on a unit exam. So for question number 1, we have an unbanked corner. The first thing we have to ask ourselves is, what keeps me from sliding out of an unbanked corner? Friction. All right. If that's the case, that means that the centripetal force is being provided by and is thus equal to the force of friction. If we don't remember that, there is no way to even get started on this question. Okay? That is one of those things we have to remember. So our givens are that the radius is 25 meters, okay, and the speed is 18 meters per second, and that's all we're given. Okay, that's all we need. So give them 1 mark if they have that. Okay, so now the next thing I have to ask myself is, all right, then what are the formulas I'm going to be using? Well, I'm going to need the formula for Fc, which is mv squared over r. Okay, and then I'm also going to need the formula that calculates the force of friction. That's mu times the normal force. How do I get normal force? It's equal to gravity because this corner is flat. Okay? It's an unbanked corner. And anytime we have that situation, gravity equals the normal force because there's no angle of bank there. Okay? So, effectively then, we have this. All right, give them a mark if they've got something like that, or if they have mu Fn, that's fine as well. Okay? So I'm trying to solve for the coefficient of friction. So to do that, I need to divide both sides by m times g. That'll make m cancel, and g will come over here. All right, so what we'll end up with is that mu equals v squared over r times g. Give them a mark for that. Okay, then we got to plug in our numbers. 18 squared divided by 25 times 9.81. A mark for that. Okay, so we are going to have 18 squared divided by 25 times 9.81. Right, so we are looking at a coefficient of friction of 1.32. That's high. Yeah, it's really high. So it's like a super sticky point. Yeah, there's only 2 significant figures, so it's only 1.3. Yeah. Okay, and there's no units on that because it's coefficient of friction. So that's what they should have for their 5th and final mark. Sorry, still only out of 4? Oh, then I gave too many marks. No mark for, they get a mark for that, sorry. Okay, all right. Any other questions on number 1? For question number 2, we have a vertical circular motion question in question number 2. All right, so the first thing we want to do is write down what the question told us. We're going over the top of a hill. That means we're there, going over the top of a vertical circle. Okay, we know that the mass of the motorcycle is 180 kilograms, and we know the speed of the motorcycle is 45 meters per second. We also know the apparent weight. Which force is that? The normal force. Okay, that's why I went over that and actually had you guys write it down yesterday. Okay, I wrote on there. This is often called Fn equals apparent weight. Okay, so Fn is 350 newtons. All right, so those are my givens. 1 mark for that. For a vertical circle, Fc is equal to the forces acting into the circle minus forces out of the circle. Okay, so on here then, I kind of want to draw a free body diagram so I can figure out which forces are out and which forces are in. What force is that? That's the force of gravity. It's the inward force. Okay? Because it's pulling me, or the motorcycle, onto the hill is going to push back, so this force will be out, but what force is it? Normal force. Okay, so I've got normal force, okay, and I've got force of gravity, and I know which one is which. Right, so we're going to have that FC equals m times g minus 350 newtons. All right with that? Okay. Now, I want to find the radius of the hill. That's going to be part of this. So we'll give them a mark if they've got something about forces in minus forces out. Maybe they had Fg minus Fn, something like that. Give them a mark for that. Okay, so what we're going to have is mv squared over r equals m times g minus 350 newtons. I need to get r by itself. This is the tricky part of the manipulation. What should I do with r right now? Multiply it over to this side. What that does is this. It's multiplying everything on that side by r. So now how do I move all that other stuff back over? Divide it. Okay, so I'm going to have m times v squared divided by mg minus 350. Okay. That's going to equal r. Okay, so give them a mark if they've got that manipulation. That's their third mark. Okay, we're going to plug in our numbers here. So that's going to be 180 times 9.8, or sorry, 180 times 45 squared divided by 180 times 9.81 minus 350. We have a mark for that. Okay, divided by 180 times 9.81 minus. Okay, so we're looking at a hill that has a radius of 257 meters, but we only have 2 significant digits, so that answer is actually going to end up as 2.6 times 10 to the 2 meters. For their fifth and final one.
You just did it all in one form. Yeah, did you just manipulate it all?
Yeah, I manipulated it to all one thing. You could do this. You could do this piecemeal if you wanted to. You're going to come out with the same answer. Okay. All right. Give them a mark out of 9, and let them see it, and then I will take them up front here.